Okay, first of all, so I categorize the topics today. So first of all, I talk about the IPC, and after that, I talk about the duplicating the descriptor, and finally, I talk about the popen. Okay, first of all, I talk about the unnamed part. But as you know that, so I open up the discussion for the IPC from the last session. So we said that IPC, or inter-process communication, it means that if two processes, they are going to communicate with each other, so they need to basically use a kind of a standard method. So last session we talked about signal, and we said that signal is a type of old-fashioned method for IPC, but through signal we can only basically send a notification or send a signal to the process, and we don't use signal for basically sending data, exchanging data to the processes. So this is regarding to the last session. But this session, so I'm going to introduce you basically the other types of IPC, but mainly for the lab, so you need basically unnamed part. But anyway, I try to introduce you some other methods of the IPC, just as a very brief description of them, so because maybe you need them. Apart from the unnamed pipes, we have a named pipe as well. So named pipe is just a kind, also is called FIFO. If you need a type of basically persistent communication between the processes, so it means that so you suppose that you have some processes that they need to communicate, but when the processes basically terminates, and then they just maybe after a while they come again to the memory. So we need to have a persistent communication. Okay, so we can use basically FIFO. But if your processes they are located over the network, so over the network you are going to have a type of communication between the processes, you can use socket. Or maybe you can use basically shared memory in order to have a communication. But you should basically consider that if you use shared memory, so in the local environment or even in the distributed environment, so you need to basically synchronize access to the shared memory, through the semaphores or maybe through the mutexes. But also there is another type, for example, message pathing. So we can use message pathing between the processes. So we have this message pathing in the local environment. Also we have message pathing over the distributed environment, just like MPI. But so let's back to talk about the unnamed part. So if you are going to open basically an unnamed part, so simply you need a pipe, and so you need to pass basically an array with two elements. So we use it basically indicating that the file descriptor for input and output to the pipe. And so the written value of the pipe is just saying that this function is basically was successful or not. But so let's talk about some hints for the unnamed pipe. Usually we use unnamed pipe when in the scenario that basically for the processes that we have a type of relationship between them, so we can use unnamed pipe. For example, processes like a child and parent. If you need to basically exchange data between the child and parent, so the best way is just using the pipe. But what is the reason behind? The reason behind is that if you use fork or if you use exec, so the file descriptor that basically you created for the pipe is inherited from the parent, and so in this way without any problem, so we can start a communication. And some other thing is that so we usually use unnamed pipe just in a local environment. So we don't use it in a distributed environment. And another thing is that basically unnamed pipe it is always in the memory. Unlike a named pipe. So named pipe basically we use a file, and so it's a kind of persistent, and so we have some things on the file system for the communication, and because of this is called named pipe. But for the unnamed pipe is just in the memory, and so because we don't assign a name, so we call it basically unnamed pipe. And another thing that is really important is unnamed pipe is a one way of communication, so it's not bidirectional. So maybe just one process is sending data to the other part, and so but other part cannot basically respond to something to receive. It's a one-way communication. And another thing is that, okay, so because unnamed pipe, as I said before, okay, is in the memory. So if the process, or if the process is that they are using pipe, it just terminate, so the pipe also will be closed. Okay. So in order to vanish into closing the pipe, so maybe the process can close the pipe, or maybe if the process is just terminate, also the pipe is terminate. But this is unlike a named pipe, because the named pipe is using a file for the communication. Even if the process is terminate, still the file is just there, and so we can use it for the future. Okay. So another thing that is really important is that reading and writing to the pipe is a kind of blocking function. If you are going to read from an empty pipe, so it will be kind of blocking function. And if you are going to write to a pipe that is full, it will be also a type of blocking function. But blocking function, it means that, okay, the process, the execution will be suspended. Okay, but suspended till when? For example, for reading, if you are trying to read from an empty pipe, so the read will be blocked till the other party writes something to the pipe, and so we can receive that, okay, so, and then the process will go on. And so because of this feature of the pipe, that it has basically the nature of the blocking, so we can use it for synchronization. Okay?
Can be or must be? It's always blocking.
As a default is blocked, but you can change the default behavior. Okay? But as a default it is blocked.
So basically, if a process opens this pipe, it's like you are going to suspend your just wait. For example, if you read something in that pipe and you wait get something from your child,
you will block. If your child already just inserted something to the pipe, yeah, and something is there is no block.
Yeah.
So you read it and then it passes.
Okay.
But if, for example, your child didn't put something in the pipe, and so you try to read, but it's empty, so it will be blocked till your children generate some things and then you pass.
Okay.
So because of this, you can use it as a type of synchronization. Yes. And so because of, but synchronization is totally, as a concept, is totally something different from the IPC. IPC, we use it for communicating with the process, but synchronization means that orchestrating the accessing of to some resources, right?
Yeah.
But here, because of the nature of the pipe, that okay, it has a read and write, but is a kind of blocking function, we can use it for the synchronization as well. And yes, okay. And the other thing is that, okay, so the maximum capacity of the unnamed pipe is basically referenced by pipe buff, okay, and at least is a kind of 512 bytes. And the another thing is that, okay, I suppose that one of your colleagues asked at the beginning of the course is just writing has atomicity or not? I mean, writing to the pipe. If you are writing to the pipe and the amount of data that you are going to write is less than basically this constant value here, so basically the pipe it guarantees that we have atomicity. Okay, but it's really important because you can share a pipe among some processes. It's an environment variable, so we can yes. So we can use it, but yes, but usually at least so we can put it for 512. But you can increase it.
And is equal to bytes?
Yes, bytes. Yes, bytes. Yeah. Okay, so this is all regarding to the unnamed part. And okay, any question or something? Atomic, it means that atomic. So who knows about the atomic? Because I said atomic and no one asked. Yes, you asked. But atomic, so no one, someone knows? Instantaneous. It seems that, okay, the atomic, it means that, okay, but so the problem of basically why the synchronization, we need synchronization, for example, between the read and write, because we cannot guarantee that, okay, writing something is a kind of atomic operation. Because maybe at the middle of the writing something, for example, you have a kind of context switch. So the scheduler basically so change the process and give the process to another one, so and it may cause a problem. But atomic, it means that okay, at the middle of execution, we guarantee that there is no other problem. So we write it so as a unique operation. Okay, and okay, this one, and another thing is that okay, so how can we basically okay, so as I said, so the pipe is just working with the file descriptor, right? And so so sometimes you need to basically duplicating your file descriptor. But how we can duplicate a file descriptor? So we have some functions, for example, dup and dup2. So we can use these functions for duplicating your file descriptor. But how basically do they work? So I just try to illustrate it here in this part. So as you know that, okay, so we have std in, std out, and std error, right? So std in, it means that, okay, as an input, the descriptor is indicating by 0, is always, okay? For the process that is just running, the descriptor 0 is just indicating the std in. And std out by 1 and std error by 2, okay? So I'm trying to explain basically dup, okay? And so you suppose that okay, you close your first descriptor 0, right? And so in this way, so the situation is just like this. I have std out as a 0, I have std error as a 2, okay? And then if I try to basically use dup, and as a parameter into the dup, we are going to duplicating a file descriptor. So it means that I should have already a descriptor in order to duplicate it, right? And I'm going to, for example, in this situation, I'm going to duplicating the descriptor of the first descriptor here. So I need to pass to dup, and then the return value that is new ft, okay? So it would be exactly identical with 1. So the new ft is a copy of the duplication of the 1, okay? But how the dup work? So dup try to from the beginning try to search in the descriptors and find an empty place. So because already basically we close 0, and so here basically the new ft will be located here in the 0 state. Okay, and so because these two are the same, I mean 1 by new ft, they are just identical. Okay. If you just write some things to 1, it means that okay, you are write some things to new ft. So both of them, so it would be the same. But so okay, as I told you that dup itself, it tries to search, okay, from the low order, try to find basically an empty descriptor. Okay. But we have another function that is basically called dup2.
So this gets dup2.
std out. Yes. Yeah. No, honestly. And so we have another one is dup2. So dup2, it means that we are not giving basically delegating the task of searching for finding the empty basically descriptor. So we are saying that okay, please use this descriptor. I mean that as a duplication. Okay. So first of all, I need to introduce one old descriptor. I'm saying that okay, I need to duplicate this old one, and so instead of delegating the task of finding the first empty basically descriptor, I'm giving basically a new descriptor here. And after executing of the dup2, if it's just successful, so the old ft and new ft, both of them basically they would be identical. Okay. But what will happen if the new ft already is opened in the system? So basically silently the dup2 tries to close the new ft and then use it, and after that open it and you use it for the old ft. Okay. So this is basically this is dup2. So we use these two basically function for basically okay. So I say function because I'm not sure. I didn't check. I'm not sure. Okay, which of them they are exactly system call and which of them they use system call in their implementation. Okay. And the other thing that is just the last thing is just using pipe, fork, and invoking the shell. So do you remember that the system, actually system is system call. So do you know what is the system? What does it do? System.
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 Ah,
What's that?
Let's
It's a shell, and then you can pass
the
a command. So you can pass the command and as a string, and so but it creates one process, right? It creates one process, and then there, so it tries to execute your command. Okay, but here you can do the same with popen. You can do the same things like system, but here you have with the popen. So you have more flexibility. So I mean that, okay, invoking the shell, so let's see that till here is exactly the same as system. Invoking a shell and also forking. So because you are generating one new process and also invoking the shell command, okay? Invoking the shell in order to run your command. So it will be the same as the system. But popen, it has one more thing, and it's basically opening the pipe in order to have a communication. Okay. So the popen, but what are the arguments of the popen? So we can pass the command here, and we can indicate the type. And this type is basically, we are saying that, okay, after opening up basically this process executing this command, we are going to read or we are going to write, basically. I mean, as a communication with this process, with this new generated process, we are going to read the output, or we are going to give some things to this process. Okay, and so you can indicate it by basically by the second argument as a type. But here the point is that as a written value of the popen, so you can use that in order to communicate. So just write some things to the process, or maybe reading the output of the execution command. But when you are going to close, instead of using that, and because if you remember, so when we had the file, so usually we used which function do we use for closing? If you have f close, yeah. Because but here instead of using f close, we must use p close. Okay. So p close and also the popen. Okay, so they should be used in the same manner. Okay.
So, if for example you want to run a shell command from your C file, for example, you can use this with the command and you specify read, for example.
For example, if you are going to if you are going to use a shell, run a shell command, and then for example read the output of your execution, the output of your shell command. So you can use popen because you run it there, and after that, so you can read the output.
Yeah. Okay.
So you can use it. But with system, you cannot use that. With system, you can just only execute the shell command. You cannot communicate with your process.